Welcome to the Boilermaker Red Seal exam practice. This video contains 120 practice questions to help you prepare for your certification exam. Let's begin. This exam covers the following major work activities: performs common occupational skills, performs rigging and hoisting, completes new construction, and performs repairs, maintenance, upgrading and testing. Question 1. When preparing to grind slag from a weld on a pressure vessel, which combination of personal protective equipment should a Boilermaker select for this task? A. Face shield, safety glasses underneath, leather gloves, and hearing protection. B. Tinted welding lens, cotton gloves, steel-toed boots, and dust mask. C. Safety glasses only with leather apron and rubber-soled boots. D. Welding helmet with clear lens, nitrile gloves, and ear plugs. The correct answer is A. Grinding operations on pressure vessels produce flying debris, sparks, noise, and fine metal particles. A face shield provides primary impact protection, safety glasses underneath serve as secondary eye protection if the shield is lifted, leather gloves protect hands from heat and sharp edges, and hearing protection guards against the sustained high decibel noise of grinding. Tinted welding lenses are inappropriate for grinding as they reduce visibility. Cotton gloves offer no heat or cut resistance. Nitrile gloves would melt from grinding sparks. The correct combination addresses all hazards simultaneously. Question 2. What is the primary purpose of a hot work permit in a Boilermaker work environment? A. To track daily labor hours and material costs for welding activities. B. To ensure fire prevention measures are verified before cutting or welding begins. C. To certify that the welder has current qualifications for the process used. D. To document the sequence of welds required for a fabrication project. The correct answer is B. A hot work permit is a documented authorization that verifies fire prevention measures are in place before any cutting, welding, brazing, or other spark-producing work begins. The permit process requires a thorough inspection of the surrounding area for combustible materials, confirms fire extinguishing equipment is available and accessible, designates a fire watch person, and establishes the duration and scope of the work. This is especially critical in Boilermaker environments where vessels may have contained flammable substances or where insulation and other combustibles are present nearby. Question 3. Before a Boilermaker enters a boiler drum for tube inspection, what must the atmospheric testing confirm? A. Oxygen level above 25% and zero combustible gases detected. B. Oxygen between 19.5 and 23% with combustible gases below 10% of the lower explosive limit. C. Temperature below 30 degrees Celsius and humidity under 50%. D. Carbon dioxide below 5% and positive air pressure inside the drum. The correct answer is B. Before entering a confined space such as a boiler drum, atmospheric testing must confirm oxygen levels are between 19.5 and 23%. Levels below 19.5% are oxygen deficient and dangerous, while levels above 23% create an oxygen-enriched atmosphere that increases fire and explosion risk. Combustible gases must be below 10% of the lower explosive limit to provide a safety margin. An oxygen reading above 25% would be dangerously enriched. Temperature and humidity alone do not determine if the atmosphere is safe to breathe. These parameters are established to protect workers from asphyxiation, explosion, and toxic exposure. Question 4. A Boilermaker is setting up a work area around a vessel that requires welding repairs. What is the correct procedure for establishing fire prevention controls? A. Remove combustibles within the work radius, cover immovable ones with fire-resistant blankets, and position fire extinguishers nearby. B. Notify the client that welding will occur and proceed with standard operations. C. Cover all combustible materials with plastic sheeting to protect them from sparks. D. Relocate welding operations to a designated welding bay regardless of vessel location. The correct answer is A. Establishing fire prevention controls requires a systematic approach. Combustible materials within the designated work radius must first be removed wherever possible. Materials that cannot be moved, such as wooden structures or insulation, must be covered with fire-resistant blankets or welding curtains to prevent ignition from sparks and spatter. Fire extinguishers appropriate for the materials present must be positioned within immediate reach. Plastic sheeting is itself combustible and would create a fire hazard. Simply notifying the client does not constitute fire prevention. Moving the welding is often impractical when repairing vessels in place. Question 5. What type of respiratory protection should a Boilermaker wear when air carbon arc gouging inside a vessel? A. Standard dust mask rated for nuisance-level particulates. B. Half-face cartridge respirator with organic vapor filters. C. Supplied air respirator due to the high volume of fumes and limited ventilation. D. No respiratory protection is needed if mechanical ventilation is running. The correct answer is C. Air carbon arc gouging generates extremely high volumes of metal fumes, carbon particles, and toxic gases. When performed inside a vessel, the confined nature of the space means fumes accumulate rapidly and natural ventilation is inadequate. A supplied air respirator provides clean breathing air from an external source, ensuring the worker is not dependent on the ambient atmosphere. Dust masks and half-face cartridge respirators cannot handle the volume and variety of contaminants produced. Mechanical ventilation alone is insufficient inside a vessel because it cannot guarantee breathable air at the worker's breathing zone during heavy gouging operations. Question 6. When using a combination square to verify a 90-degree fit-up on a plate joint, how should the Boilermaker confirm the tool is reading accurately? A. Compare the reading against a protractor placed on the same joint surface. B. Check the square against a known straight edge and inspect the blade for damage or looseness. C. Measure the joint from both sides and average the two readings together. D. Hold the square up to a light source and look for visible gaps along the edge. The correct answer is B. Before relying on a combination square for critical fit-up measurements, a Boilermaker should verify its accuracy by checking it against a known straight edge such as a machined surface or precision straight edge. The blade should be inspected for bending, nicks, or looseness in the head assembly, as any of these conditions can produce false readings. A protractor is a different measuring tool with its own potential for error. Averaging two measurements does not correct for a faulty tool. While checking for light gaps can indicate gross errors, it does not verify the tool's inherent accuracy against a known reference. Question 7. A Boilermaker is using a pneumatic die grinder to smooth a weld inside a small diameter vessel nozzle. What precaution is most important for this operation? A. Operating the grinder at maximum speed to reduce overall grinding time. B. Using a grinding disc rated for a larger grinder to increase surface coverage. C. Wrapping the air hose around the wrist to prevent the tool from dropping. D. Ensuring the air supply has a regulator set to the tool's rated pressure and using appropriately sized burrs. The correct answer is D. Pneumatic die grinders must be operated with a regulated air supply set to the manufacturer's rated pressure. Exceeding the rated pressure causes the tool to spin faster than its design speed, which can cause burrs or mounted points to shatter. Appropriately sized burrs must match the grinder's collet and speed rating. Running at maximum speed without proper pressure regulation is dangerous. Using discs rated for a different tool creates a serious risk of disc failure. Wrapping the air hose around the wrist creates an entanglement hazard that could pull the operator into the work or prevent quick release in an emergency. Question 8. What is the function of a plate roll in a Boilermaker shop? A. To cut flat plate stock into strips of uniform width for fabrication. B. To punch bolt holes along the edges of plate material before assembly. C. To flatten warped plate stock that has been distorted by welding heat. D. To form flat plate into curved sections for vessel shells and cylinders. The correct answer is D. A plate roll, also called a plate rolling machine or bending roll, is used to form flat plate stock into curved shapes such as cylindrical shells, cones, and segments for pressure vessels, tanks, and stacks. The machine uses 3 or 4 heavy rollers to progressively bend the plate to the desired radius. Plate rolls are fundamental shop equipment in boilermaking because vessel construction requires forming flat material into round or curved components. Cutting is performed by shears or torches, punching is done by iron workers or drill presses, and flattening of distorted plate is typically done with a press or by mechanical straightening. Question 9. When setting up an oxyfuel cutting torch to cut 25 mm carbon steel plate, what is the correct sequence of operations? A. Set regulators first, open both cylinder valves simultaneously, purge lines, then ignite with acetylene and oxygen together. B. Open acetylene cylinder fully, open oxygen 1/4 turn, ignite acetylene first, then slowly add oxygen. C. Open oxygen cylinder valve fully, open acetylene valve 1/4 turn, set regulators to recommended pressures, then purge each line before igniting. D. Purge lines with both gases flowing, set regulators after ignition, then adjust flame to neutral. The correct answer is C. The correct setup sequence for oxyfuel equipment requires opening the oxygen cylinder valve fully to ensure full flow capacity and to seat the back seal on the valve. The acetylene valve is opened only 1/4 to 1/2 turn so it can be shut off quickly in an emergency. Regulators are then set to the manufacturer's recommended pressures for the tip size and material thickness. Each line must be purged individually before igniting to remove any mixed gases in the hoses. The torch is lit with acetylene first, then oxygen is added to establish the correct flame. Opening both valves simultaneously or setting regulators after ignition creates dangerous conditions. Question 10. A boilermaker needs to erect tubular scaffolding along the exterior of a large horizontal vessel for insulation removal. What must be done before workers can use the scaffold? A. Each worker should test the scaffold by climbing it individually before loading tools. B. The scaffold must be loaded with maximum anticipated materials to test its strength. C. Guardrails are only required on the top level if the scaffold exceeds 4 tiers. D. A competent person must inspect the scaffold and confirm it meets safety requirements. The correct answer is D. Before any scaffold can be used by workers, a competent person must inspect it to confirm it meets all applicable safety requirements. This inspection verifies that the scaffold is properly erected on firm footing, all cross-bracing is in place, planking is secured and fully decked, guardrails and toe boards are installed on all open sides and ends, and the scaffold has adequate capacity for the intended loads. Having individual workers test the scaffold is not a valid inspection method. Preloading to maximum capacity could cause collapse if there are deficiencies. Guardrails are required at heights where fall protection is mandated, regardless of the number of tiers. Question 11. What type of equipment is a boom lift classified as in Boilermaker work? A. A fixed-position work platform designed for permanent installation at height. B. A manually operated scaffolding system with adjustable height capability. C. An aerial work platform that provides elevated positioning through a hydraulic boom. D. A crane attachment used exclusively for personnel hoisting during rigging. The correct answer is C. A boom lift is classified as an aerial work platform. It uses a hydraulic boom mechanism, either articulating or telescoping, to elevate workers and their tools to elevated positions. Boom lifts are mobile, self-propelled units that provide flexibility in reaching work areas at various heights and horizontal distances. They are commonly used in boilermaking for accessing elevated sections of vessels, stacks, and structural components. Unlike fixed platforms, boom lifts can be repositioned as needed. They are distinct from scaffolding, which is a static temporary structure, and from crane-mounted personnel baskets, which serve a different purpose under separate regulations. Question 12. A boilermaker is using a torque wrench to tighten flange bolts on a manway cover. What practice ensures consistent and accurate bolt loading? A. Tightening each bolt fully in clockwise sequence around the flange pattern. B. Applying maximum torque on the first pass to reduce the number of tightening rounds. C. Using an impact wrench for initial tightening and the torque wrench for final verification. D. Following a star pattern across the flange and tightening in multiple progressive passes. The correct answer is D. Flange bolts on manway covers and other pressure-containing joints must be tightened using a star or cross pattern in multiple progressive passes. This technique ensures even gasket compression and prevents warping of the flange. Each pass incrementally increases the torque, typically in 3 or more stages, until the final specified torque value is reached. Tightening in a clockwise sequence causes uneven loading that can distort the gasket and create leaks. Applying full torque on the first pass causes localized compression and flange distortion. While impact wrenches may be used for initial snugging, the star pattern and progressive tightening must still be followed with the calibrated torque wrench. Question 13. Before using a portable electric drill on a wet vessel platform, what should the Boilermaker verify about the tool's electrical safety? A. The drill has been recently lubricated and the chuck key is attached with a tether. B. The drill is battery operated and does not require any additional precautions in wet conditions. C. The drill's voltage matches the generator output and the bit is properly centered. D. The drill is connected through a ground fault circuit interrupter and the cord is free of damage. The correct answer is D. When using a portable electric drill in wet or damp conditions, electrical safety is the primary concern. The tool must be connected through a ground fault circuit interrupter, which will cut power almost instantly if current leakage is detected, protecting the worker from electrocution. The power cord must be inspected for cuts, abrasion, or exposed conductors, as damage increases the risk of shock in wet conditions. While lubrication, chuck security, voltage matching, and bit centering are all valid maintenance and operational checks, they do not address the specific electrical hazard created by water on the work surface. Question 14. What is the purpose of a hydraulic ironworker machine in a Boilermaker fabrication shop? A. To punch holes, shear plate, notch angles, and cut bar stock using hydraulic force. B. To bend and shape round bar stock into custom rings and saddle profiles. C. To weld structural steel components together using automated welding heads. D. To roll and form heavy plate into cylindrical sections for vessel fabrication. The correct answer is A. A hydraulic ironworker is a versatile shop machine that performs multiple metalworking operations using hydraulic force. Its standard functions include punching holes in plate and structural shapes, shearing flat plate and bar stock, notching angles and channels, and cutting bar stock. The machine uses interchangeable die sets and blade configurations for each operation. It is a staple in Boilermaker fabrication shops because it efficiently handles many common tasks on structural and plate materials. Bending round bar is done on a bender or mandrel, automated welding uses separate equipment, and plate rolling is done on plate roll machines. Question 15. A Boilermaker is planning the work sequence for a vessel repair that requires scaffolding, insulation removal, welding, and hydrostatic testing. What is the correct order of operations? A. Welding, scaffolding erection, insulation removal, then hydrostatic testing. B. Scaffolding erection, insulation removal, welding, then hydrostatic testing. C. Insulation removal, hydrostatic testing, welding, then scaffolding erection. D. Hydrostatic testing, scaffolding erection, insulation removal, then welding. The correct answer is B. The correct sequence for a vessel repair begins with scaffolding erection to provide safe access to the work area. Insulation must then be removed to expose the vessel surface that requires repair. Welding repairs are performed on the exposed vessel wall, and hydrostatic testing is conducted last to verify the integrity of the completed repair under pressure. Each step depends on the previous one. You cannot remove insulation without access, you cannot weld through insulation, and you must complete all welding before testing. Planning work sequences correctly prevents rework, ensures safety, and maintains project efficiency. Question 16. On an isometric drawing of a vessel, a Boilermaker sees a weld symbol with a V-groove on the arrow side, a backing bar symbol, and a field weld flag. What does this combination indicate? A. A fillet weld with a permanent backing ring installed during shop fabrication. B. A plug weld with a removable ceramic backing applied in the field location. C. A flare bevel weld with supplementary filler metal added during post-weld treatment. D. A V-groove weld with a backing bar performed at the job site rather than in the shop. The correct answer is D. Interpreting weld symbols requires understanding each element. The V-groove on the arrow side indicates the weld joint preparation is a V-shaped bevel on the side of the joint the arrow points to. The backing bar symbol, shown as a rectangle on the opposite side of the reference line, indicates that a backing bar will be used to support the root of the weld. The field weld flag, represented by a filled triangle at the junction of the reference line and arrow, indicates this weld is to be performed at the erection site rather than in the fabrication shop. Together, these elements tell the Boilermaker to prepare and execute a V-groove weld with backing bar support as a field operation during vessel erection or repair. Question 17. When an overhead crane is used to move a heavy vessel head in a fabrication shop, what is the minimum requirement for the lifting attachments? A. Lifting attachments must be rated for the load and inspected before each use. B. Lifting attachments should be selected based on availability and convenience. C. Lifting attachments need only be inspected when visible damage is present. D. Lifting attachments require annual certification but no daily inspection. The correct answer is A. Lifting attachments such as shackles, slings, spreader bars, and hooks used with overhead cranes must meet two minimum requirements. They must be rated for the weight of the load being lifted, and they must be inspected before each use. Load ratings ensure the attachment has sufficient capacity with an appropriate safety factor. Pre-use inspection catches wear, deformation, cracks, or damage that could cause failure under load. Selecting attachments based on convenience alone ignores capacity requirements. Waiting until visible damage is present to inspect means a compromised attachment could be used unknowingly. Annual certification alone is insufficient because damage can occur between certification intervals. Question 18. A Boilermaker is reviewing a piping and instrumentation diagram, P and inside diameter, to locate isolation points before vessel maintenance. What information does the P and inside diameter provide for this task? A. Detailed weld joint preparation specifications and material grade requirements. B. Valve locations, pipe routing, instrumentation connections, and process flow direction. C. Dimensional tolerances for pipe supports and structural steel anchor bolts. D. Scaffolding requirements and access platform locations around the vessel. The correct answer is B. A piping and instrumentation diagram provides a schematic representation of the process system, showing valve locations with their types and identifiers, pipe routing and connections, instrumentation such as pressure gauges and temperature sensors, and the direction of process flow. This information is essential for identifying isolation points because the Boilermaker must know where valves are located, what type they are, and how the piping connects to the vessel to establish effective isolation for safe maintenance. Weld specifications appear on welding procedure documents, dimensional tolerances on fabrication drawings, and scaffolding requirements on separate access plans. Question 19. A Boilermaker needs to store alloy steel fittings on site until they are ready for installation. What handling practice prevents material contamination? A. Stacking alloy fittings directly on carbon steel shelving to save space. B. Marking the alloy fittings with a chloride-based paint marker for identification. C. Placing alloy fittings in direct contact with concrete flooring in a covered area. D. Storing alloy fittings on wooden dunnage separate from carbon steel materials. The correct answer is D. Alloy steel fittings must be stored separately from carbon steel materials to prevent carbon contamination through direct contact. Carbon transfer from carbon steel to alloy surfaces can compromise the corrosion resistance and metallurgical properties of the alloy material. Wooden dunnage provides a non-metallic barrier between the fittings and any carbon steel surfaces. Stacking alloy on carbon steel shelving causes direct contact contamination. Chloride-based markers can cause stress corrosion cracking on certain alloy steels, particularly stainless grades. Concrete flooring can trap moisture and contaminants that could affect the fittings. Proper material segregation and handling is essential to maintaining material integrity. Question 20. What activities are included in the demobilization process after completing a vessel construction project on site? A. Removing temporary facilities, cleaning the site, returning rented equipment, and completing project documentation. B. Ordering additional materials and scheduling follow-up inspections for the next phase. C. Performing final welding repairs and conducting the acceptance hydrostatic test. D. Submitting shop drawings and requesting engineering approvals for design changes. The correct answer is A. Demobilization is the process of closing out a construction site after the work is complete. It includes removing temporary facilities such as tool cribs, lunch trailers, and temporary power connections. The site must be cleaned of construction debris, scrap materials, and waste. Rented or leased equipment such as cranes, welding machines, and scaffolding must be returned to suppliers. Project documentation including as-built drawings, inspection records, and material certificates must be completed and submitted. Ordering materials and scheduling follow-up work are planning activities. Final welding and testing are production activities. Engineering submissions are design activities. Demobilization specifically deals with the orderly closure and cleanup of the work site. Question 21. During a pre-job meeting for a pressure vessel repair, what information should a Boilermaker communicate to the work crew? A. Personal opinions on the best welding techniques and preferred tool brands to use. B. Estimated project costs, material supplier contact information, and billing codes. C. General company policies, upcoming social events, and vacation scheduling details. D. Scope of work, identified hazards, required permits, and emergency procedures for the task. The correct answer is D. A pre-job meeting, also called a toolbox talk or tailgate meeting, is a critical communication opportunity before starting work. The Boilermaker leading the meeting should clearly communicate the scope of work so everyone understands what will be performed, identified hazards specific to the task and location, required permits such as hot work or confined space entry permits, and emergency procedures including evacuation routes and muster points. This ensures all crew members are aware of the risks, controls, and expectations before work begins. Personal opinions on techniques are not safety-critical communications. Cost information and company social events are administrative matters handled through other channels. Question 22. A journeyperson Boilermaker is mentoring an apprentice who is learning to read vessel fabrication drawings. What is an effective mentoring approach? A. Providing the apprentice with a textbook and allowing them to study independently. B. Assigning the apprentice to observe other trades to gain a broader understanding first. C. Reviewing actual shop drawings together and explaining symbol meanings in the context of current work. D. Testing the apprentice on drawing interpretation before providing any instruction. The correct answer is C. Effective mentoring connects learning to real work situations. Reviewing actual shop drawings together allows the journeyperson to explain weld symbols, dimensions, material specifications, and assembly sequences in the context of work the apprentice will perform. This approach reinforces learning by connecting abstract symbols to tangible components the apprentice can see and touch. Independent textbook study lacks the practical context needed for skill development. Observing other trades does not build Boilermaker-specific drawing skills. Testing before instruction creates a negative learning experience and does not transfer knowledge. Hands-on, contextual instruction is the most effective way to develop technical comprehension skills in an apprentice. Question 23. Why is accurate documentation of completed work activities important for a Boilermaker on a vessel construction project? A. It creates a traceable record for quality assurance, regulatory compliance, and future maintenance reference. B. It allows the Boilermaker to claim overtime hours without supervisor approval. C. It provides material for writing personal performance reviews at year-end evaluations. D. It satisfies union reporting requirements but has no practical impact on project quality. The correct answer is A. Accurate documentation of completed work activities creates a traceable record that serves multiple essential purposes. For quality assurance, it verifies that work was performed according to specifications and procedures. For regulatory compliance, it demonstrates that the vessel was constructed or repaired in accordance with applicable codes and standards, which is required for registration and insurance. For future maintenance, it provides a reference for anyone who needs to inspect, repair, or modify the vessel later, knowing what was done previously. Documentation is not a mechanism for claiming unauthorized overtime. While it may support performance evaluations, that is not its primary purpose. It has direct practical impact on project quality and vessel safety throughout its operating life. Question 24. A boilermaker needs to remove a cracked section of a pressure vessel shell using air carbon arc gouging. What is the correct technique for controlling the gouging process? A. Push the carbon electrode at a steep angle with low amperage to minimize material removal. B. Hold the electrode perpendicular to the plate surface and use a weaving motion across the crack. C. Maintain a shallow electrode angle, use steady travel speed, and direct the air jet behind the arc to blow molten metal clear. D. Use a small diameter electrode with high travel speed to prevent excessive heat buildup. The correct answer is C. Air carbon arc gouging requires specific technique for effective and controlled material removal. The carbon electrode should be held at a shallow angle, typically 35 to 45 degrees, to the workpiece surface. Travel speed must be steady and consistent to produce a uniform groove depth and width. The air jet must be directed behind the arc to blow molten metal clear of the groove, preventing reposition of material. A steep angle drives the arc too deep and is difficult to control. Holding the electrode perpendicular creates an erratic gouging pattern. While high travel speed does reduce heat input, using a small diameter electrode limits the groove width and may require multiple passes, increasing overall heat exposure. Proper technique ensures complete removal of defective material while maintaining controlled groove geometry for subsequent weld repair. Question 25. A boilermaker prepares a joint on a thick-walled chrome moly vessel. The procedure specifies a double V bevel with a 2 mm root face. The root face has been ground to less than 1 mm in several locations. What should be done? A. Build up the root face with correct filler material and regrind to the specified 2 mm dimension. B. Proceed with higher amperage to ensure full penetration through the thinner root face. C. Increase the root gap to compensate for the reduced root face thickness. D. Continue as is because a thinner root face will improve penetration. The correct answer is A. The correct action is to build the root face back up with weld metal using appropriate filler material, then regrind to 2 mm. The root face dimension controls penetration, prevents burn-through, and maintains joint geometry required by code. On chrome moly material, precise heat input control is essential. Proceeding with a thinner root face risks burn-through and uncontrolled geometry. Increasing amperage adds more heat, compounding the problem. Widening the root gap changes the joint design beyond the qualified procedure. Any deviation on pressure-containing joints must be corrected, not compensated for with improvised adjustments. Question 26. What is the purpose of using bridge clamps and wedges when fitting two vessel shell sections together? A. To permanently join the shell sections without the need for welding. B. To provide corrosion protection at the joint during outdoor storage. C. To maintain alignment and root gap dimensions while tack welding is performed. D. To measure the ovality of each shell section before positioning. The correct answer is C. Bridge clamps and wedges are temporary fitting aids used to hold vessel shell sections in proper alignment during fit-up and tack welding. Bridge clamps span across the joint and draw the two sections together, while wedges are used to fine-tune the gap between sections to achieve the specified root opening. These devices maintain alignment and gap dimensions so that tack welds can be placed in a controlled joint geometry. Once tack welding is complete and the joint is stabilized, the clamps and wedges are removed. They are temporary mechanical aids, not permanent fasteners or measurement tools. Corrosion protection is achieved through coatings and proper storage, not through fit-up clamps. Question 27. When tack welding a circumferential joint on a vessel shell, how should the tack welds be sequenced to minimize distortion? A. Place all tack welds consecutively around the circumference starting from the bottom. B. Apply one large tack weld at the top of the joint and one at the bottom only. C. Place tack welds at opposing positions around the circumference, such as 12 o'clock, then 6 o'clock, then 3 o'clock, then 9 o'clock. D. Tack weld from one side of the joint only to allow for thermal expansion. The correct answer is C. Tack welds on a circumferential vessel joint must be placed at opposing positions to minimize distortion and maintain uniform root gap. The sequence follows a pattern similar to tightening flange bolts, the first tack at 12 o'clock, the second directly opposite at 6 o'clock, the third at 3 o'clock, and the fourth at 9 o'clock, with additional tacks placed between these positions as needed. This opposing sequence distributes shrinkage forces evenly around the circumference. Placing tacks consecutively allows cumulative shrinkage that pulls the gap closed in the untacked area. 2 tacks alone are insufficient to control a circumferential joint. Tacking from one side creates asymmetric restraint that distorts the joint alignment. Question 28. A Boilermaker is performing SMAW on a vessel nozzle using 7018 low hydrogen electrodes. Midway through, the coating begins to flake off and the arc becomes erratic. What is the most likely cause and correct response? A. The electrode absorbed moisture, discard it and use one from a heated rod oven. B. The base metal is too cold, increase travel speed to reduce heat input. C. The welding machine voltage is too high, switch to a different polarity. D. The plate surface is contaminated, continue welding to burn through it. The correct answer is A. Low hydrogen 7018 electrodes are highly sensitive to moisture. When the coating absorbs moisture, it breaks down during welding, causing flaking, and an unstable arc. Moisture introduces hydrogen into the weld deposit, which can cause hydrogen-induced cracking in pressure vessel welds. The correct response is to discard the affected electrode and obtain a properly stored one from a rod oven maintained at 120 to 175 degrees Celsius. Continuing with a moisture-damaged electrode risks serious defects requiring costly repair. These symptoms are characteristic of moisture contamination, not base metal temperature, machine settings, or surface contamination. Question 29. What is the primary advantage of plasma cutting over oxyfuel cutting for stainless steel plate? A. Plasma cutting produces wider kerfs that simplify subsequent joint preparation. B. Plasma cutting requires no electrical power and operates on compressed gas alone. C. Plasma cutting can cut stainless steel while oxyfuel cutting cannot effectively cut it. D. Plasma cutting eliminates the need for eye protection during the cutting process. The correct answer is C. Plasma cutting has a fundamental advantage over oxyfuel cutting when working with stainless steel. It can cut stainless steel effectively, while oxyfuel cutting cannot. Oxyfuel cutting relies on a chemical reaction between the oxygen stream and iron in the base metal to produce the cutting action. Stainless steel contains chromium, which forms a refractory oxide layer that resists this oxidation reaction, making oxyfuel cutting ineffective. Plasma cutting uses a superheated ionized gas to melt and blow away the material regardless of its oxidation characteristics, making it effective on stainless steel, aluminum, and other non-ferrous metals. Plasma cutting actually produces a narrower kerf than oxyfuel. It requires electrical power to generate the arc. Eye protection is always required for plasma cutting due to the intense arc light. Question 30. A Boilermaker is about to begin GMAW welding on a carbon steel vessel saddle using solid wire and a shielding gas mixture. What pre-weld check should be performed on the shielding gas system? A. Verify the gas is pure oxygen to ensure maximum arc penetration into the base metal. B. Ensure the gas cylinder is stored horizontally to maintain consistent delivery pressure. C. Test the gas by directing the flow at a lit match to verify combustibility before welding. D. Confirm the correct gas mixture is connected and check the flow rate at the nozzle for adequate coverage. The correct answer is D. Before starting GMAW welding, the Boilermaker must verify that the correct shielding gas mixture is connected by checking the cylinder label. Common mixtures for carbon steel include 75% argon with 25% carbon dioxide, or pure carbon dioxide, depending on the welding procedure specification. The flow rate at the nozzle must be checked to ensure adequate gas coverage of the weld pool, typically between 15 and 25 liters per minute. Insufficient flow allows atmospheric contamination causing porosity, while excessive flow creates turbulence that draws air into the gas stream. Pure oxygen would cause violent oxidation and is never used as a shielding gas. Gas cylinders must be stored upright and secured. Shielding gases are inert or mildly reactive and should never be tested with an open flame. Question 31. Which welding process uses a non-consumable tungsten electrode and is commonly used by Boilermakers for root passes on high-quality vessel joints? A. Shielded metal arc welding using flux-coated consumable electrodes. B. Flux-cored arc welding using a continuously fed tubular wire with flux inside. C. Submerged arc welding using granular flux and a continuously fed bare wire electrode. D. Gas tungsten arc welding using a non-consumable tungsten electrode with separate filler rod. The correct answer is D. Gas tungsten arc welding, also known as GTAW or TIG welding, uses a non-consumable tungsten electrode to produce the arc while a separate filler rod is fed manually into the weld pool. An inert shielding gas, typically argon, protects the tungsten and the molten weld pool from atmospheric contamination. GTAW is the preferred process for root passes on critical vessel joints because it provides superior control over heat input, penetration, and weld bead profile. The process produces very clean, high-quality welds with minimal defects. Boilermakers commonly use GTAW for root passes and then fill the remainder of the joint with SMAW or FCAW for productivity. Shielded metal arc welding uses consumable electrodes. Flux-cored arc welding uses tubular wire. Submerged arc welding uses granular flux and is an automated process. Question 32. When calculating the weight of a steel plate for a lift plan, what formula is used to determine the total weight? A. Length multiplied by width multiplied by the specific gravity of the plate material only. B. Length multiplied by width multiplied by thickness multiplied by the density of the material. C. Surface area of the plate multiplied by a standard correction factor for steel thickness. D. Circumference of the plate multiplied by height multiplied by a material weight constant. The correct answer is B. The weight of a steel plate is calculated by determining its volume, length x width x thickness, and then multiplying by the density of the steel. For mild steel, the density is approximately 7,850 kilograms per cubic meter. This fundamental calculation allows Boilermakers to accurately determine load weights before selecting rigging equipment and planning the lift. Accurate weight calculations are critical because overloading rigging equipment can lead to catastrophic failure. The Boilermaker must also account for any additional items attached to the plate such as brackets, stiffeners, or lifting lugs that add to the total weight being rigged. Question 33. What is the center of gravity of a load? A. The highest point on the load where a sling can be safely attached for lifting. B. The point at which the entire weight of the load is considered to be concentrated. C. The lowest point on the load where it contacts the ground or supporting surface. D. The geometric center of the load as measured from its outermost visible edges. The correct answer is B. The center of gravity is the single point at which the entire weight of an object is considered to be concentrated. When a load is supported at its center of gravity, it remains balanced and level. If the rigging attachment points are not positioned directly above the center of gravity, the load will tilt toward the heavier side during the lift. Boilermakers must determine the center of gravity before rigging to ensure the load remains stable and controlled throughout the lifting operation. For symmetrical loads of uniform density, the center of gravity is at the geometric center, but for irregular shapes or loads with uneven weight distribution, it must be calculated or determined through testing. Question 34. A cylindrical steel vessel has an outside diameter of 1,200 mm, a length of 3,000 mm, and a wall thickness of 12.7 mm. Which approach correctly determines its approximate weight? A. Calculate the volume of steel in the shell walls and multiply by the density of steel. B. Multiply the outside diameter by the length to find the surface area and apply a flat weight factor. C. Calculate the total enclosed volume of the cylinder and multiply by the full density of solid steel. D. Measure the vessel circumference and multiply by the length and then by a per foot weight table. The correct answer is A. To determine the weight of a hollow cylindrical vessel, a Boilermaker must calculate the volume of steel in the shell walls rather than treating the vessel as a solid object. This involves calculating the cross-sectional area of the annular ring, the area between the outer and inner diameters, and multiplying by the vessel length. The result is then multiplied by the density of steel to obtain the weight. Additional weight from heads, nozzles, flanges, and internal components must be added separately. Treating the vessel as solid would vastly overestimate the weight, while using only surface area would not account for the wall thickness that determines the actual mass of steel present. Question 35. During a pre-lift analysis for an outdoor boiler component lift, which environmental condition requires the lift to be postponed? A. Sustained wind speeds exceed the crane manufacturer's maximum operating limit. B. Ambient temperature has dropped below 10 degrees Celsius at the lift location. C. Light rainfall is occurring but visibility remains greater than 100 meters. D. Cloud cover is at 90% and daylight is expected to last for 2 more hours. The correct answer is A. When sustained wind speeds exceed the crane manufacturer's maximum operating wind speed limit, the lift must be postponed. Wind creates dynamic lateral forces on the load that are difficult to predict and control, especially on large surface area components common in boiler work. High winds can cause the load to swing uncontrollably, increase the effective load radius, and exceed the structural limits of the crane boom. The crane load chart is calculated under calm conditions, and wind forces are not factored into the rated capacities. Temperature alone, light rain with good visibility, and cloud cover do not typically require postponement unless they create additional hazards such as icing on rigging or loss of visibility. Question 36. What is the primary purpose of conducting a pre-lift meeting before a critical lift? A. To determine the exact weight of the load using field measurement techniques. B. To calibrate the crane load moment indicator before the lifting operation begins. C. To verify the serial numbers on all rigging hardware against inventory records. D. To communicate the lift plan details and assign roles to all personnel involved. The correct answer is D. The primary purpose of a pre-lift meeting, also called a toolbox talk or tailboard meeting, is to communicate the lift plan details and assign specific roles to all personnel involved in the lifting operation. This includes reviewing the lift sequence, crane positioning, load weight, rigging configuration, travel path, landing zone, signal person assignments, and emergency procedures. Every worker must understand their specific role and the overall plan before the lift begins. While weight determination, equipment calibration, and hardware verification are important activities, they occur during the planning and inspection phases before the pre-lift meeting takes place. Question 37. When selecting a shackle for a rigging application, what determines the appropriate shackle size? A. The physical dimensions and surface area of the load being lifted. B. The working load limit of the shackle relative to the calculated sling tension. C. The color coding stamped on the shackle body by the original manufacturer. D. The diameter of the crane hook where the shackle will be attached during the lift. The correct answer is B. The appropriate shackle size is determined by comparing the working load limit, WLL, of the shackle to the calculated sling tension in the rigging configuration. The sling tension accounts for the load weight, the number of sling legs, and the sling angle. The selected shackle must have a WLL that meets or exceeds the maximum force that will be applied to it during the lift. Additionally, the pin diameter must be large enough to properly seat in the sling eye or fitting being connected. Shackles are never selected based on color coding or crane hook size alone, and load dimensions do not directly determine shackle capacity requirements. Question 38. A two-leg sling bridle is used to lift a 4,500 kilogram load. If each sling leg makes a 60-degree angle with the horizontal, what is the approximate tension in each sling leg? A. Approximately 1,900 kilograms per leg due to the favorable steep sling angle. B. Exactly 2,250 kilograms per leg because the load divides equally between two legs. C. Approximately 3,200 kilograms per leg due to the acute angle multiplier applied. D. approximately 2,600 kilograms per leg because of the sling angle tension factor. The correct answer is D. When a two-leg sling bridle lifts a load, the tension in each leg is greater than simply half the load weight because of the sling angle. The tension in each leg equals the load per leg divided by the sine of the angle from horizontal. With a 60-degree angle from horizontal, the sine of 60 degrees is 0.866. Each leg supports half the load, 2,250 kilograms, so the tension per leg is 2,250 divided by 0.866, which equals approximately 2,600 kilograms. This demonstrates why sling angles are critical in rigging calculations. As the angle from horizontal decreases, the tension in each leg increases dramatically. At a 30-degree angle, the same load would create approximately 4,500 kilograms of tension per leg. Question 39. What is the minimum recommended sling angle measured from the horizontal when rigging a load? A. 15 degrees from horizontal to keep the sling legs spread wide for load stability. B. 30 degrees from horizontal to provide an adequate margin on sling leg tension. C. 45 degrees from horizontal to balance sling tension with adequate load stability. D. 60 degrees from horizontal to ensure the sling legs remain nearly vertical under load. The correct answer is C. The minimum recommended sling angle measured from the horizontal is 45 degrees. At angles less than 45 degrees, the tension in the sling legs increases rapidly and can exceed the working load limit of the slings. At a 30-degree angle from horizontal, each sling leg experiences a tension equal to the full weight of its share of the load, tension factor of 2.0, effectively doubling the force compared to a vertical lift. The 45-degree minimum provides a reasonable balance between maintaining manageable sling tensions and allowing practical rigging geometry. Steeper angles, closer to vertical, reduce sling tension but require taller headroom and longer crane boom reach. Question 40. What must be established around the lift area before a crane begins hoisting operations? A. Temporary lighting towers positioned at each corner of the crane operating radius. B. Ground-level vibration sensors to monitor soil stability throughout the lifting operation. C. Secondary anchor points for the crane outriggers using driven steel ground stakes. D. Barricades and warning signage to prevent unauthorized personnel from entering the area. The correct answer is D. Before hoisting operations begin, barricades and warning signage must be established around the lift area to prevent unauthorized personnel from entering the danger zone beneath or near the suspended load. This is a fundamental safety requirement for all lifting operations. The barricaded area must encompass the full swing radius of the crane and the potential fall zone of the load. Only essential personnel with assigned roles in the lift operation should be permitted inside the barricaded area. Warning signs should clearly indicate that overhead lifting is in progress and that entry is restricted to authorized personnel only. Question 41. Why must the ground conditions at the crane setup location be evaluated before positioning the crane for a lift? A. To determine if the ground surface color contrasts sufficiently with the crane for visibility. B. To ensure the ground can support the combined weight of the crane and the load being lifted. C. To verify that the ground surface is level enough for workers to walk without tripping hazards. D. To confirm that underground utilities have been marked with the correct paint color codes. The correct answer is B. Ground conditions must be evaluated to ensure the soil or surface can support the combined weight of the crane, its counterweights, the outrigger loads, and the load being lifted. Crane outriggers concentrate enormous forces onto relatively small areas of ground. If the ground is soft, unstable, recently backfilled, or undermined by underground voids, the crane can sink, shift, or tip over during the lift. The evaluation includes checking soil bearing capacity, identifying underground utilities or voids, verifying that outrigger pads or mats are adequate to distribute the loads, and ensuring proper compaction. Ground failure under a loaded crane is one of the leading causes of crane accidents in the field. Question 42. Who is responsible for directing the crane operator during a hoisting operation using hand signals? A. The project manager who approved the lift plan documentation before operations began. B. A designated signal person who has been assigned and identified before the lift begins. C. Any qualified tradesperson standing in the general vicinity of the crane and load. D. The rigging foreman who planned the lift but may not maintain visual contact with the load. The correct answer is B. A designated signal person must be assigned and identified to all parties before the lift begins. This person is responsible for directing the crane operator using standardized hand signals or radio communication. Only one signal person directs the crane at a time to prevent confusion from conflicting instructions, although the signal person role may be transferred during the lift if the load must travel out of one person's line of sight. The signal person must maintain clear visual contact with both the load and the crane operator at all times. Any worker can give an emergency stop signal, but only the designated signal person provides operational direction during the lift. Question 43. During a pre-use inspection of wire rope slings, which condition requires the sling to be immediately removed from service? A. Bird caging is observed where the outer strands have separated and bulged from the core. B. Minor surface rust is visible on the outer wires of the sling body near the thimble end. C. A thin layer of lubricant residue is present on the outer surface of the wire rope strands. D. Small amounts of dirt and grit are embedded between the outer strands of the wire rope. The correct answer is A. Bird caging is a severe and irreversible form of wire rope damage where the outer strands separate from the core and bulge outward, resembling the wires of a bird cage. This condition indicates that the rope has been subjected to a sudden release of tension or has been improperly loaded, causing permanent structural damage. A wire rope sling showing bird caging must be immediately removed from service and destroyed because the internal structure is compromised and the sling can fail without warning under load. Minor surface rust, lubricant residue, and embedded dirt are normal conditions that may require cleaning or maintenance but do not mandate immediate removal from service. Question 44. When inspecting a synthetic web sling before use, what type of damage requires the sling to be taken out of service? A. Light surface scuffing on the outer protective cover of the webbing material. B. Slight discoloration of the sling material from exposure to normal sunlight. C. A small amount of oil or grease contamination on the surface of the web sling. D. Cuts or tears that expose the inner load-bearing yarns of the sling webbing. The correct answer is D. Cuts or tears that expose the inner load-bearing yarns of a synthetic web sling require the sling to be immediately removed from service. The outer webbing provides protection to the internal structural fibers that carry the load. Once these fibers are exposed or damaged, the sling capacity is reduced in an unpredictable manner, and the sling can fail suddenly under load. Synthetic slings are also vulnerable to damage from sharp edges, chemicals, ultraviolet radiation, and heat. Light surface scuffing, minor discoloration, and small amounts of surface contamination typically do not compromise the structural integrity of the sling, although chemical exposure should be evaluated based on the specific substance involved. Question 45. What information is found on the identification tag of a wire rope sling? A. The rated capacity, sling diameter, and sling length for the intended hitch type. B. The purchase date, vendor contact details, and recommended replacement schedule. C. The name of the last inspector and the date of the most recent load test performed. D. The storage location code and the department number assigned to the sling owner. The correct answer is A. The identification tag on a wire rope sling provides critical information including the rated capacity, working load limit, 4 different hitch configurations, the wire rope diameter, the overall sling length, and the manufacturer's identification. This information is essential for selecting the correct sling for a given lift. The rated capacity varies depending on whether the sling is used in a vertical, choker, or basket hitch configuration, and these capacities are listed on the tag. Without a legible identification tag, the sling cannot be used because the Boilermaker has no verified means to confirm the sling's rated capacity. Slings with missing or unreadable tags must be removed from service. Question 53. What must be checked on a chain hoist before it is used for a lifting operation? A. The paint finish on the housing must be intact to confirm the unit has not been overloaded. B. The chain links must be free of gouges, stretching, and excessive wear at bearing points. C. The serial number plate must match the purchase order number in the equipment database. D. The suspension hook must rotate freely with no resistance when spun by hand continuously. The correct answer is B. Before using a chain hoist, the load chain must be inspected for gouges, stretching, and excessive wear at the bearing points where links contact each other in the sprocket. Stretched links indicate the chain has been overloaded, and they prevent the chain from seating properly on the lift wheel or sprocket, which can cause the chain to jump or jam during operation. Gouges and wear reduce the cross-sectional area of the link material, lowering the chain's load capacity below its rated value. The hooks, safety latches, and brake mechanism must also be inspected. Paint condition is not a reliable indicator of overloading, and while the hoist must be identifiable, matching serial numbers to purchase orders is an administrative task rather than a safety inspection item. Question 59. When performing a tandem lift using two cranes to place a large boiler component, what is the most critical factor to coordinate between the two crane operators? A. Both cranes must be the same manufacturer and model to ensure identical hydraulic response. B. Both cranes must lift and travel at the same rate to prevent one crane from taking excess load. C. Both cranes must have their booms at identical angles to maintain symmetry during the lift. D. Both crane operators must have the same years of experience to ensure equal skill levels. The correct answer is B. In a tandem, dual crane, lift, the most critical coordination factor is ensuring both cranes lift, travel, and lower at the same rate. If one crane moves faster than the other, the load shifts and one crane takes a disproportionate share of the total weight. This unequal load distribution can quickly exceed the rated capacity of the more heavily loaded crane, leading to potential crane failure or tipping. Tandem lifts require detailed lift plans, experienced operators, and a single designated signal person to direct both cranes simultaneously. The cranes do not need to be the same model, but each must have sufficient capacity for its planned share of the load plus a safety factor for dynamic load redistribution. Constant communication between operators is essential throughout the operation. Question 60. After a load has been lowered to its final resting position, when is it safe to remove the rigging? A. Immediately upon ground contact while the crane is still holding partial load on the slings. B. Before the load reaches the ground to allow the rigger quicker access to the attachment points. C. after the load is fully supported on its landing surface and the slings are completely slack. D. After the crane has moved to a new position and the boom is swung away from the load area. The correct answer is C. Rigging can only be removed after the load is fully supported on its final resting surface and the hoisting equipment has been lowered enough to make the slings completely slack. This confirms that no tension remains in the rigging and the full weight of the load has been transferred to the supporting structure or ground. Removing rigging while the slings are still under tension is extremely dangerous because the stored energy in the sling can cause it to whip or recoil when released, and the load could shift unpredictably if it has not fully settled. The load must also be verified as stable and secure on its supports before personnel approach to disconnect the rigging hardware. Question 61. What must be done to secure a vessel on temporary supports before the rigging is removed after a lift? A. Place cardboard shims under the vessel to protect the surface finish of the support steel. B. Immediately disconnect all rigging so the crane can proceed to the next scheduled lift task. C. Attach permanent welded brackets to the vessel while the rigging is still carrying the load. D. Verify that the vessel is stable, level, and properly supported before slackening the slings. The correct answer is D. Before rigging can be removed, the Boilermaker must verify that the vessel is stable, level, and properly supported on its temporary supports. This means checking that the supports are correctly positioned under the designated bearing points, that the vessel is not rocking or shifting, and that the supports can carry the full weight of the vessel without sinking, sliding, or tipping. Only after stability is confirmed should the slings be gradually slackened to transfer the load from the crane to the supports. The transfer should be done slowly so that any problems with the supports can be detected while the crane is still in position to resupport the load if necessary. Rushing to remove rigging before confirming stability creates a serious risk of the vessel falling from its supports. Question 62. During a post-lift inspection, a rigger discovers that one wire rope sling shows visible deformation at the thimble eye where the shackle pin was seated. The sling was loaded within its rated capacity. What is the most likely cause and correct course of action? A. The shackle pin was the wrong size for the thimble eye, and the sling must be removed from service. B. The sling was stored improperly and should be reshaped by straightening the thimble manually. C. The deformation is cosmetic from normal use and the sling can be returned to service after oiling. D. The crane operator raised the load too quickly and the sling should be used at reduced capacity. The correct answer is A. Visible deformation at the thimble eye when the sling was loaded within its rated capacity most likely indicates that an incorrectly sized shackle pin was used. A pin that is too small concentrates the load on a narrow area of the thimble, causing localized deformation. A pin that is too large can spread the thimble eye. In either case, the thimble no longer provides proper protection to the wire rope eye, and the sling must be removed from service for professional inspection and potential refabrication. This finding also requires a review of the rigging plan to ensure correct hardware matching in future lifts. The deformation is not cosmetic and cannot be repaired by manual straightening, which would further weaken the affected area. This scenario demonstrates why post-lift inspections are essential for identifying developing equipment problems before they cause failures. Question 63. What is the primary purpose of conducting a post-lift inspection of rigging equipment? A. To calculate the exact weight that was lifted for billing and project cost tracking records. B. To identify any damage or wear sustained during the lift so unsafe equipment is removed. C. To document the crane operator's performance rating for the company's annual review process. D. To verify the serial numbers of the rigging hardware against the pre-lift equipment manifest. The correct answer is B. The primary purpose of a post-lift inspection is to identify any damage or wear that the rigging equipment may have sustained during the lifting operation. Rigging components can be damaged by contact with sharp edges, overloading, impact with structures, or improper use during the lift. Post-lift inspection catches these issues before the equipment is stored and later selected for another lift where it could fail. Damaged equipment identified during post-lift inspection must be tagged out of service, removed from the usable inventory, and either repaired by qualified personnel or destroyed. Without consistent post-lift inspections, damaged rigging can remain in the equipment pool and eventually cause a catastrophic failure during a subsequent lifting operation. Question 64. When disassembling a multi-part rigging arrangement after a lift, what is the correct sequence for removing components? A. Remove components in the reverse order of assembly, starting from the hook end downward. B. Remove all shackles first regardless of position, then remove slings and other hardware. C. Cut the slings at midspan with a torch to allow rapid disassembly and save site time. D. Remove the components closest to the load first and then work upward toward the hook. The correct answer is A. When disassembling a multi-part rigging arrangement, the correct procedure is to remove components in the reverse order of assembly, typically starting from the crane hook end and working downward toward the load. This sequence ensures that the upper components are freed first while the lower components still secure the load against any residual movement. Removing components in a random or incorrect order can allow the remaining rigging to shift unpredictably, potentially dropping or rolling a load that has not been fully secured on its supports. Cutting slings is wasteful and creates sharp wire rope ends that are a laceration hazard. All rigging hardware should be handled carefully during disassembly and inspected for damage before being stored for future use. Question 67. When using trammel points to scribe a large radius arc on a vessel shell plate, what is the correct procedure for setting the trammel bar? A. Set the trammel points slightly oversized and then file down the scribed line to achieve the required dimension. B. Tighten only one trammel point and allow the other to float freely during the scribing operation. C. Lock the trammel points at the required radius and verify the setting against a steel rule before scribing the arc. D. Clamp the trammel bar directly to the plate surface and rotate the workpiece beneath the fixed scriber. The correct answer is C. When using trammel points for layout on vessel shell plates, the correct procedure is to lock both trammel points securely at the required radius and verify the dimension against a calibrated steel rule before scribing. This ensures the arc will be accurate to the fabrication drawing dimensions. Trammel points must be firmly locked to prevent any movement during scribing, as even slight shifts can produce an arc that deviates from the required radius. Verifying the setting before scribing prevents costly material waste on expensive pressure vessel plate. Filing down scribe lines would remove material and compromise dimensional accuracy, while allowing a point to float would produce an inconsistent arc. Question 68. What layout tool is used to transfer and mark equal distances along the surface of plate material during fabrication? A. A combination square with a protractor head for angular measurements. B. A folding rule with an inside reading extension for depth measurements. C. A bevel gauge set to the plate thickness for edge marking operations. D. Dividers set to the required spacing for stepping off equal distances. The correct answer is D. Dividers are the standard layout tool used to transfer and mark equal distances along the surface of plate material. By setting the dividers to the required spacing, a Boilermaker can step off consistent distances along a baseline by pivoting the tool alternately on each leg. This technique is essential for laying out bolt hole patterns, nozzle locations, and other equally spaced features on vessel plates. Dividers maintain their setting through repeated use, providing consistent accuracy. Combination squares measure angles, folding rules measure lengths, and bevel gauges transfer angles, but none of these are designed for stepping off equal distances. Question 69. When laying out a full-size template for a vessel head segment, what method ensures accurate transfer of the pattern to plate steel? A. Tracing the outline freehand with a paint marker while holding the template against the plate edge. B. Photographing the template and projecting the image onto the plate surface at full scale. C. Measuring only the overall dimensions from the template and cutting the plate to those rough sizes. D. Securing the template flat against the plate and scribing around all edges using a soapstone or transfer punch. The correct answer is D. The correct method for transferring a full-size template pattern to plate steel is to secure the template flat against the plate surface and scribe around all edges using a soapstone or transfer punch. Securing the template prevents shifting during the transfer process, which would introduce dimensional errors. Soapstone provides a visible mark on steel that can be followed during cutting, while transfer punches create permanent witness marks at critical points. This method preserves the exact geometry of the template, including curves and notch features that are essential for proper fit-up of vessel head segments. Freehand tracing lacks precision, projection methods are impractical in shop environments, and measuring only overall dimensions would lose the contour details. Question 76. When constructing a vessel shell by fit-up of rolled plate sections, what technique is used to maintain roundness during tack welding of the longitudinal seam? A. Welding the entire longitudinal seam continuously before checking roundness to lock in the shell shape. B. Using strong backs or flat bar clamps across the seam to hold the edges in alignment during tack welding. C. Hammering the shell exterior with a dead blow mallet to force the edges into contact before any tacking. D. Leaving the seam open with a large gap and then pulling it closed with a chain come along after tacking. The correct answer is B. Strong backs or flat bar clamps are used across the longitudinal seam to hold the plate edges in proper alignment during tack welding of vessel shell sections. These devices bridge the seam and are tack welded to both plate edges, maintaining edge alignment and preventing high-low mismatch as tack welds are placed. Strong backs resist the tendency of the plate edges to shift during welding due to thermal expansion and contraction. They are placed at regular intervals along the seam length and removed after the full weld is completed. This method ensures the longitudinal seam meets the alignment tolerances required for pressure vessel construction. Welding the full seam without checking roundness could lock in out-of-round conditions, and using excessive force to close gaps indicates improper rolling. Question 77. What is the purpose of fit-up when constructing subassemblies for a pressure vessel? A. To align and temporarily secure components in their correct positions before permanent welding. B. To apply the final protective coating on all internal surfaces before the vessel is sealed shut. C. To perform the required hydrostatic pressure test on each subassembly prior to final assembly. D. To calculate the total weight of the completed vessel for lifting and transportation purposes. The correct answer is A. Fit-up in pressure vessel construction refers to the process of aligning and temporarily securing components in their correct positions before permanent welding takes place. During fit-up, the Boilermaker ensures that all joint dimensions, such as root gap, mismatch, and angular alignment, meet the specifications required by the design drawings and applicable codes. Temporary securing is typically achieved through tack welds, clamps, or fixtures. Proper fit-up is critical because it directly affects weld quality and the structural integrity of the finished vessel. Poor fit-up leads to defective welds, distortion, and potential failure under pressure. Coating, pressure testing, and weight calculations are separate activities that occur at different stages of fabrication. Question 78. When aligning a tall vertical vessel using a plumb bob, what precaution must be taken to obtain an accurate reading? A. Use the shortest possible plumb line to minimize the visual distance between the bob and the vessel. B. Attach the plumb line to the vessel itself so it moves with the vessel during the alignment procedure. C. Shield the plumb bob from wind and allow it to stop swinging completely before taking any measurement. D. Take readings only from one side of the vessel to maintain a consistent reference point throughout. The correct answer is C. When using a plumb bob to align a tall vertical vessel, the plumb bob must be shielded from wind and allowed to stop swinging completely before taking any measurements. Wind causes the plumb bob to deflect from true vertical, producing inaccurate readings that could result in the vessel being installed out of plumb. Even slight air currents in a shop or field environment can move a plumb bob enough to exceed the alignment tolerances specified for pressure vessels. Shielding can be accomplished with temporary windbreaks or enclosures around the plumb line. Readings should always be taken from at least two perpendicular sides of the vessel to confirm plumb in both directions. Attaching the plumb line to the vessel defeats its purpose as an independent vertical reference. Question 79. When using piano wire to align a long horizontal vessel, what is the correct method for establishing the reference line? A. Drape the wire loosely across the top and mark where it contacts the shell at each support point. B. Stretch the wire under tension between fixed supports at each end at a known offset from the center line. C. Thread the wire through the vessel interior so it passes through the geometric center of each head. D. Wrap the wire circumferentially at multiple stations and measure the diameter at each location. The correct answer is B. The correct method is to stretch the wire under tension between fixed supports at each end, positioned at a known offset from the center line. Sufficient tension minimizes sag, creating a straight reference line for measurements at multiple stations along the vessel. The known offset lets the Boilermaker calculate the actual centerline by measuring from wire to vessel at each station. This technique verifies shell course alignment, straightness, and saddle support positioning. Loose wire would sag and give inaccurate readings, interior routing is impractical during assembly, and circumferential measurements check roundness, not alignment. Question 80. What optical instrument is commonly used by Boilermakers to verify alignment and elevation of large vessel components during assembly? A. A laser distance meter that measures the total distance from one component to the next adjacent part. B. A builder's level or transit that provides a precise horizontal reference line for elevation checks. C. A digital inclinometer that displays the plate thickness at any point along the vessel circumference. D. A bore scope camera that allows visual inspection of internal surfaces during the alignment process. The correct answer is B. A builder's level or transit is the optical instrument commonly used by Boilermakers to verify alignment and elevation of large vessel components during assembly. This instrument establishes a precise horizontal line of sight that serves as a reference for checking the elevation of support saddles, nozzle locations, and vessel centerline positions. The transit can also be rotated to check vertical alignment and angular positioning. When combined with a graduated rod or target, measurements accurate to fractions of a millimeter can be obtained over long distances. This level of precision is essential for ensuring that large pressure vessels are assembled within the tight tolerances required by fabrication codes. Laser distance meters measure distances, inclinometers measure angles, and bore scopes are for internal inspection. Question 81. When fitting two shell courses of a pressure vessel together at a circumferential seam, what dimension must be checked and controlled? A. The total weight of both shell courses to confirm that the lifting equipment has sufficient capacity. B. The ambient temperature of the surrounding work area to determine the thermal expansion offset. C. The high-low mismatch between the inside surfaces of the two shell courses at the joint. D. The color and surface texture of the plate material to verify that both courses are the same grade. The correct answer is C. When fitting circumferential seams between shell courses, the high-low mismatch between the inside surfaces must be checked and controlled. High-low mismatch refers to the offset or step between the internal surfaces of the two adjoining shell courses at the weld joint. Excessive mismatch creates stress concentrations that can lead to fatigue cracking and reduces the effective throat of the weld joint. Fabrication codes specify maximum allowable mismatch values, typically expressed as a fraction of the plate thickness. The Boilermaker uses inside gauges, straight edges, or purpose-built high-low gauges to measure this offset at multiple points around the circumference. Adjustments are made using jacking screws, wedges, or come-alongs to bring the mismatch within tolerance before tack welding the joint. Question 82. When fitting a nozzle to a pressure vessel shell, what must be verified before tack welding the nozzle in position? A. The internal coating of the vessel has been fully cured and is ready for contact with process fluids. B. The nozzle projection, orientation, and angular position match the fabrication drawing requirements. C. The nozzle nameplate data has been recorded in the fabrication log and signed by the project manager. D. The hydrostatic test has been completed on the shell section to confirm there are no existing leaks. The correct answer is B. Before tack welding a nozzle to a pressure vessel shell, the Boilermaker must verify that the nozzle projection, orientation, and angular position match the fabrication drawing requirements. Nozzle projection refers to how far the nozzle extends from the vessel shell surface. Orientation includes the nozzle facing direction relative to vessel north and the rotational position around the vessel circumference. Angular position must match the drawing coordinates, often specified in degrees from a reference point. Incorrect nozzle placement affects piping connections, equipment clearances, and process flow requirements. Once welded, relocating a nozzle requires cutting it out and repairing the shell, which is extremely costly and time-consuming. Internal coating, nameplate recording, and hydrostatic testing are activities that occur after fabrication is complete. Question 83. What is the purpose of using leveling shims during the alignment of a horizontal vessel on its saddle supports? A. To permanently weld the saddle supports to the concrete foundation for seismic resistance. B. To bring the vessel to the correct elevation and ensure it is level within the specified tolerance. C. To reduce the contact area between the vessel and the saddle to prevent galvanic corrosion. D. To increase the overall height of the vessel so that piping connections can be made more easily. The correct answer is B. Leveling shims are used during horizontal vessel alignment to bring the vessel to the correct elevation and ensure it is level within the specified tolerance. Saddle supports are set on foundations that may have minor elevation differences due to concrete placement tolerances. Shims are inserted between the saddle base plates and the foundation to fine-tune the vessel elevation at each support point. The vessel must be level to ensure proper drainage, accurate liquid level instrument readings, and correct orientation of nozzles and internal components. Shim packs are typically made from stainless steel or carbon steel plates of various thicknesses that can be combined to achieve the required elevation adjustment. After alignment is confirmed, the shims are welded or grouted in place. Question 84. When fitting a vessel head to a shell course, what is the proper method for controlling the root gap around the circumferential weld joint? A. Fill the entire gap with weld metal before fit up to create a solid foundation for the root pass. B. Leave the gap as large as possible to allow for maximum weld penetration from the exterior side. C. Insert calibrated gap gauges or spacer strips at regular intervals and tack weld to maintain the gap. D. Grind the head edge to a knife point so it contacts the shell with no visible gap between the parts. The correct answer is C. The proper method for controlling root gap when fitting a vessel head to a shell course is to insert calibrated gap gauges or spacer strips at regular intervals around the circumference and tack weld to maintain the specified gap. The root gap is critical to weld quality because it determines whether the root pass can achieve full penetration. Too narrow a gap prevents penetration, while too wide a gap causes burn-through and excessive weld metal consumption. Calibrated gap gauges ensure the specified dimension is maintained uniformly around the entire joint. Tack welds are placed at regular intervals between the spacers to lock the gap in position before the spacers are removed and welding begins. Filling the gap with weld metal before fit-up is incorrect procedure, excessive gaps waste material, and a knife edge prep would not provide the required root opening. Question 85. When multiple nozzles must be fitted to a vessel shell, what approach prevents cumulative errors in nozzle placement? A. Fit all nozzles simultaneously by placing them loosely in their openings and adjusting them all at once. B. Reference all nozzle positions from the vessel datum points rather than measuring from adjacent nozzles. C. Start fitting nozzles from the smallest diameter first and work progressively to the largest diameter. D. Mark nozzle positions using paint rather than scribe lines to allow for repositioning if necessary. The correct answer is B. When fitting multiple nozzles to a vessel shell, all nozzle positions should be referenced from the vessel datum points rather than measuring from adjacent nozzles. Measuring from one nozzle to the next introduces cumulative errors where each small measurement deviation is added to the next, potentially causing the final nozzle to be significantly out of position. By referencing each nozzle independently from fixed datum points such as the vessel centerline, main seams, or established benchmarks, each nozzle position is independently accurate regardless of any minor deviations in other nozzle locations. This approach is standard practice in pressure vessel fabrication where nozzle positions must match piping layouts precisely. Fitting all nozzles simultaneously is impractical, sizing order is irrelevant to accuracy, and paint marks lack the precision of scribe lines. Question 86. What does the term plumb mean when used in the context of aligning a vertical vessel during construction? A. The vessel is perfectly vertical as confirmed by a plumb bob or precision level instrument. B. The vessel is centered horizontally over its foundation with equal overhang on all four sides. C. The vessel's internal volume has been calculated correctly for the specified design capacity. D. The vessel shell has been checked for uniform wall thickness at all measurement stations. The correct answer is A. In the context of aligning a vertical vessel, plumb means the vessel is perfectly vertical as confirmed by a plumb bob or precision level instrument. A vessel that is plumb has its centerline aligned with the direction of gravity. Checking plumb is essential during vertical vessel erection because even small deviations from vertical create eccentric loading on the foundation, affect liquid levels and instrument readings, and can prevent proper piping connection. Plumb is checked from at least two perpendicular directions, typically referred to as north-south and east-west, to confirm the vessel is vertical in both planes. The term originates from the Latin word plumbum meaning lead, referring to the lead weight on a plumb bob that hangs in the direction of gravity. Question 87. When fitting a large diameter manway to a vessel shell with tight mismatch tolerances, what tack welding sequence should be followed? A. Start at the top and place consecutive tack welds clockwise around the full circumference. B. Place one large tack weld at the bottom and allow gravity to settle the component into position. C. Place tack welds at opposing positions in a cross pattern to distribute fit-up forces evenly. D. Tack weld only the upper half first and then rotate the vessel to complete the lower half. The correct answer is C. Tack welds should be placed at opposing positions in a cross pattern, first at 12 o'clock, then 6, then 3, then 9, filling in between. This distributes fit-up forces evenly and prevents the manway from pulling to one side. Sequential tacking in one direction causes progressive shifting, resulting in accumulated mismatch at the closure point. A single large tack provides insufficient restraint, and tacking only half the joint allows the untacked side to move. This cross-pattern technique is fundamental to all circular fit-up operations in boiler making. Question 88. A boilermaker bolting a high-pressure vessel flange notices one bolt has reached specified torque while adjacent bolts still have significant gaps under the nuts. What is the most likely cause and corrective action? A. The gasket is too thick, replace it with a thinner gasket before continuing. B. The torque wrench is out of calibration, replace it before tightening more bolts. C. The flange faces are not parallel, disassemble and realign the flanges before retorquing. D. The bolt threads are cross-threaded, apply additional lubricant to reduce friction. The correct answer is C. When one bolt reaches torque while adjacent bolts still have gaps, the flange faces are likely not parallel. This misalignment causes uneven gasket compression. The high side contacts first and reaches torque prematurely while the low side remains open. Continuing would overload one side and undercompress the other, creating a leak path. The correct action is to disassemble, identify and correct the misalignment through piping adjustments or shimming, then rebolt properly. Replacing the gasket or wrench does not address the root cause, and adding lubricant to a cross-threaded bolt masks a damaged fastener. Question 89. What is the standard bolt tightening pattern used when torquing flange bolts on a pressure vessel? A. A star or cross pattern that alternates between bolts on opposite sides of the flange. B. A clockwise sequential pattern moving from bolt to bolt around the entire flange circumference. C. A random pattern where each bolt is selected at random until all bolts have been tightened once. D. A counterclockwise pattern starting from the bolt closest to the bottom of the flange. The correct answer is A. The standard bolt tightening pattern for pressure vessel flanges is a star or cross pattern that alternates between bolts on opposite sides of the flange. This pattern ensures that gasket compression is applied evenly across the joint, preventing flange distortion and uneven gasket loading. By tightening diametrically opposite bolts in sequence, the flange is drawn down uniformly rather than being pulled to one side. The tightening is typically performed in multiple passes at incrementally increasing torque values, such as 30%, 60%, and 100% of the final specified torque. Sequential clockwise or counterclockwise tightening would cause one side of the flange to be compressed before the other, leading to gasket damage and potential leakage. Random patterns provide no assurance of even compression. Question 90. When installing a spiral wound gasket on a raised face flange, what must be confirmed before placing the gasket? A. The gasket has been coated with pipe thread sealant on both faces to prevent leakage at lower pressures. B. The flange faces are clean and free of scratches, pitting, or damage that could create a leak path. C. The raised face height has been reduced by machining to accommodate the extra thickness of the gasket. D. The bolt holes have been elongated to allow for thermal movement during operation at elevated temperatures. The correct answer is B. Before placing a spiral wound gasket on a raised face flange, the Boilermaker must confirm that the flange faces are clean and free of scratches, pitting, or damage that could create a leak path. Spiral wound gaskets seal by conforming to the flange face finish under bolt load. Any defects in the flange face create channels through which the contained fluid can escape, even when the gasket is properly compressed. The flange face should be examined for radial scratches, corrosion pits, tool marks, and damage from previous gasket removal. Minor defects may be corrected by remachining the flange face. Applying sealant compounds to spiral wound gaskets is not recommended as it can interfere with the sealing mechanism. The raised face should not be machined down, and bolt holes should not be modified. Question 91. During tube rolling in a heat exchanger, a Boilermaker notices that the tube wall reduction exceeds the specified percentage at one tube-to-tube sheet joint. What is the consequence and required action? A. The excess wall reduction increases tube strength through work hardening and no corrective action is needed. B. The overexpanded tube is weakened and may fail in service, requiring the tube to be removed and replaced. C. The overrolled tube will simply loosen over time, requiring periodic re-rolling during maintenance intervals. D. The extra expansion improves the seal quality and the joint should be left as is for best sealing performance. The correct answer is B. When tube wall reduction exceeds the specified percentage during rolling, the tube has been overexpanded. Overrolling thins the tube wall beyond the design limit, weakening the tube and reducing its ability to withstand internal pressure and thermal cycling. The tube material may also develop microcracks from excessive cold working. An overrolled tube can fail in service, causing a leak between the tube side and shell side fluids, which may create safety hazards and equipment damage. The correct action is to remove the defective tube by drilling or collapsing it out of the tube sheet and installing a replacement tube. Overrolling does not improve strength through work hardening beyond a certain point, instead, it causes embrittlement. The joint does not simply loosen over time, and the excess expansion does not improve seal quality. Question 92. What is the typical target wall reduction percentage when rolling tubes into a tube sheet for a standard heat exchanger application? A. Approximately 5 to 8% wall reduction to ensure a seal while maintaining tube wall integrity. B. Approximately 1 to 2% wall reduction to provide a light press fit with minimal tube deformation. C. Approximately 15 to 20% wall reduction to maximize the contact area between tube and tube sheet. D. Approximately 25 to 30% wall reduction to work harden the tube material for increased strength. The correct answer is A. The typical target wall reduction for rolling tubes into a tube sheet in standard heat exchanger applications is approximately 5 to 8%. This range provides sufficient expansion to create a tight seal between the tube outer diameter and the tube sheet bore while maintaining adequate tube wall thickness for pressure containment and service life. Wall reduction is calculated by comparing the tube wall thickness before and after rolling, or by measuring the change in tube inner diameter. Values below 5% may not provide a reliable seal, while values above 8% begin to overthin the tube wall and risk damage. The exact target depends on tube material, wall thickness, tube sheet material, and the specific design requirements. Torque-controlled or length-controlled tube rollers are used to achieve consistent wall reduction across all joints. Question 93. When laying up fiberglass on a tank surface, what procedure ensures proper bonding between successive layers of fiberglass mat? A. Allow each layer to fully cure and harden before applying any resin for the next successive layer. B. Apply the next layer of mat dry and then inject resin between the layers using a syringe after placement. C. Wet out each layer with resin and apply the next layer while the previous layer is still tacky. D. Stack all layers of dry mat together at once and then saturate the entire layup with resin in a single pour. The correct answer is C. Proper fiberglass layup requires wetting out each layer with resin and applying the next layer while the previous layer is still tacky. This wet-on-tacky technique ensures that the resin from adjacent layers intermingles at the interface, creating a strong chemical bond between layers. If the previous layer is allowed to fully cure before the next is applied, the bond between layers is significantly weaker because the cured resin surface does not chemically bond as effectively with fresh resin. Each layer must be thoroughly wetted with resin and rolled to remove air bubbles before the next layer is placed. The roller forces resin through the fiberglass mat and eliminates voids that would weaken the laminate. Applying dry mat first and injecting resin afterward cannot achieve uniform saturation, and stacking all layers at once traps air and prevents proper wet out. Question 94. What is the primary purpose of using a ribbed roller during fiberglass layup operations on a vessel surface? A. To apply a uniform layer of gel coat over the fiberglass surface for aesthetic appearance. B. To remove trapped air bubbles from the laminate and consolidate the resin-saturated mat layers. C. To trim the excess fiberglass mat from the edges of the layup area after resin application. D. To heat the resin by friction so it cures faster during the layup of each successive layer. The correct answer is B. The primary purpose of a ribbed roller, also called a bubble roller or paddle roller, during fiberglass layup is to remove trapped air bubbles from the laminate and consolidate the resin-saturated mat layers. Air bubbles trapped within or between layers create voids that significantly weaken the laminate structure. These voids reduce the effective cross-section of the laminate and act as stress concentration points that can initiate cracking under load or chemical attack. The ribbed surface of the roller channels air to the edges of the layup as it is rolled across the wet surface. The roller also helps distribute resin evenly through the mat and compress the layers together for maximum interlaminar bond strength. Gel coat application, trimming, and resin heating are not functions of the ribbed roller. Question 95. When performing a visual inspection of a pressure vessel shell, what is the first step a Boilermaker should take to identify wall thinning from internal corrosion? A. Immediately drill test holes through the shell to check remaining wall thickness. B. Apply welding heat to the suspect area and observe the color change pattern. C. Clean the surface and look for localized pitting, discoloration, and scale deposits. D. Pressurize the vessel to maximum allowable working pressure before inspection. The correct answer is C. Visual inspection for internal corrosion begins with thorough surface cleaning followed by careful examination for telltale indicators such as localized pitting, discoloration, and accumulations of scale or corrosion products. These surface conditions reveal areas where the metal has been attacked and wall thinning may have occurred. Drilling test holes is destructive and would compromise vessel integrity. Applying welding heat serves no diagnostic purpose and could damage the vessel. Pressurizing to maximum pressure before inspecting for defects is extremely dangerous, as weakened areas could rupture under load. A systematic visual survey provides the initial assessment that guides subsequent non-destructive examination methods. Question 96. Which non-destructive examination method uses a magnetic field and ferrous particles to detect surface and near-surface cracks in carbon steel vessels? A. Liquid penetrant testing applied to the component surface. B. Radiographic testing using gamma-ray film exposure. C. Magnetic particle testing using a yoke or prod technique. D. Ultrasonic thickness testing with a straight beam probe. The correct answer is C. Magnetic particle testing. Magnetic particle testing is the non-destructive examination method that uses a magnetic field applied to ferromagnetic materials to detect surface and near-surface discontinuities. When a magnetic field is induced in the component using a yoke or prods, any crack or defect disrupts the field and attracts the ferrous particles, dry powder or wet suspension, to the defect location, creating a visible indication. Liquid penetrant testing detects only surface-breaking defects through capillary action and does not use magnetic principles. Radiographic testing uses penetrating radiation to create images of internal defects on film. Ultrasonic thickness testing uses sound waves to measure remaining wall thickness but does not employ magnetic particles. Question 97. A Boilermaker discovers bulging on the shell of a horizontal storage vessel during inspection. What does this condition most commonly indicate? A. The vessel was manufactured with an intentional reinforcement pad. B. External painting was applied unevenly during the last maintenance cycle. C. The support saddles were recently adjusted to redistribute the vessel load. D. The vessel has experienced localized overheating or excessive internal pressure. The correct answer is D. Bulging on a pressure vessel shell is a serious defect that typically indicates the metal has been subjected to localized overheating, excessive internal pressure, or a combination of both. When steel is heated beyond its design temperature, it loses tensile strength and begins to deform plastically under operating pressure, creating a visible outward bulge. This can also result from flame impingement, loss of refractory lining, or internal deposit buildup that causes hot spots. Bulging is not an intentional design feature. Uneven paint application does not cause metal deformation. Saddle adjustment changes load distribution but does not produce shell bulging. Any bulging found during inspection requires engineering assessment to determine if the vessel can continue in service safely. Question 98. Before servicing a pressure vessel that contained hydrocarbon vapors, what preparation step ensures a safe work environment inside the vessel? A. Draining residual liquid and immediately entering the vessel with supplied air. B. Closing all isolation valves and waiting 24 hours for vapor dispersal. C. Opening the manway cover while the vessel remains at operating temperature. D. Purging the vessel with an inert gas followed by fresh air ventilation and atmospheric testing. The correct answer is D. Preparing a vessel that contained hydrocarbons for safe internal work requires a systematic approach. First, the vessel is depressurized and drained, then purged with an inert gas such as nitrogen to displace the flammable hydrocarbon vapors below their lower explosive limit. After inerting, fresh air ventilation replaces the nitrogen atmosphere to establish breathable conditions. Atmospheric testing then confirms oxygen levels are adequate and toxic or flammable gas concentrations are within safe limits before entry. Simply draining and entering with supplied air does not address explosive vapor concentrations. Closing valves and waiting does not reliably remove trapped vapors from internal surfaces and dead legs. Opening a manway while the vessel is hot risks thermal burns and uncontrolled vapor release. Question 99. What is the purpose of installing blanks or blinds on piping connections when isolating a vessel for internal servicing? A. To increase the flow capacity of the connected piping system during operation. B. To support the weight of attached piping while the vessel is out of service. C. To provide positive isolation preventing any process fluids from entering the vessel. D. To protect the pipe flanges from atmospheric corrosion during maintenance. The correct answer is C. Blanks, also called blinds or spectacle blinds, are installed at flange connections to provide positive mechanical isolation of the vessel from connected process piping. This ensures that no process fluids, whether liquid, gas, or vapor, can inadvertently enter the vessel while workers are inside performing maintenance or repairs. Valve isolation alone is not considered positive isolation because valves can leak, be inadvertently opened, or fail. Blanks physically block the pipe bore and create a verified barrier. They do not increase flow capacity, as they completely block flow. Pipe supports, not blanks, carry piping weight. While blanks do cover flange faces, corrosion protection is not their primary purpose during vessel isolation. Question 100. When excavating a crack in a pressure vessel shell for weld repair, what method is used to confirm the crack has been completely removed before welding? A. Measuring the excavation depth with a ruler and comparing to the original wall thickness. B. Filling the excavation with water and checking for seepage on the opposite side. C. Performing magnetic particle or liquid penetrant testing on the excavated surface. D. Grinding the area smooth and verifying it visually under normal shop lighting. The correct answer is C. After excavating a crack from a pressure vessel, non-destructive examination such as magnetic particle testing or liquid penetrant testing must be performed on the excavated cavity surface to confirm complete crack removal. These methods can detect any remaining crack tips or branching that are invisible to the naked eye. Simply measuring depth does not confirm whether the crack extends deeper or has lateral branches. Water testing at atmospheric pressure cannot reliably detect tight remaining cracks. Visual inspection alone, even with good lighting, cannot detect fine crack remnants that may propagate under service pressure. Only NDE methods provide the sensitivity needed to verify that the entire defect has been removed and the surface is suitable for weld repair. Question 101. What is the primary reason for applying preheat to a pressure vessel shell before performing a weld repair on a thick carbon steel section? A. To slow the cooling rate and reduce the risk of hydrogen-induced cracking. B. To increase the welding travel speed and reduce overall repair time. C. To improve the color contrast of the weld bead against the base metal. D. To eliminate the need for post-weld heat treatment after the repair is completed. The correct answer is A. Preheat is applied to thick carbon steel sections before weld repair primarily to slow the cooling rate of the weld zone. Rapid cooling of carbon steel welds creates hard, brittle microstructures in the heat-affected zone that are highly susceptible to hydrogen-induced cracking, also called cold cracking or delayed cracking. By raising the base metal temperature before welding, the thermal gradient is reduced, cooling occurs more slowly, and hydrogen has more time to diffuse out of the weld zone rather than becoming trapped. Preheat does not significantly affect travel speed or arc characteristics. Weld bead color contrast is irrelevant to preheat purpose. While preheat helps, it does not eliminate the requirement for post-weld heat treatment when specified by the welding procedure specification. Question 102. What document specifies the essential welding variables that a Boilermaker must follow when performing a weld repair on a pressure vessel? A. The original vessel purchase order and shipping manifest. B. the manufacturer equipment maintenance schedule and service log. C. The plant operator daily shift report and inspection checklist. D. The welding procedure specification approved for the repair application. The correct answer is D. A welding procedure specification. Welding procedure specification is the document that defines all essential welding variables for a given application, including the welding process, filler metal type and size, preheat and interpass temperatures, voltage and amperage ranges, travel speed, shielding gas composition, and post-weld heat treatment requirements. Boilermakers must follow the approved welding procedure specification to ensure the repair weld meets the mechanical and metallurgical properties required for the vessel's service conditions. The purchase order contains commercial information, not welding parameters. The maintenance schedule tracks service intervals but does not define welding variables. Operator shift reports document operational data but are not welding procedure documents. Question 103. When installing a flush patch plate on a corroded section of a pressure vessel shell, what is the correct sequence of preparation steps? A. Mark the repair boundary, cut out the damaged section, bevel the edges, fit the patch plate, and tack weld in position. B. Weld the patch plate directly over the corroded area without removing any damaged material first. C. Bevel the patch plate edges, press it into the opening before cutting, then trim the excess material. D. Cut the patch plate oversized, force it through the vessel opening, and grind it flush from inside. The correct answer is A. Installing a flush patch plate requires a methodical sequence to ensure structural integrity. First, the repair boundary is marked beyond the extent of the corrosion damage to reach sound metal. The damaged section is then cut out cleanly, typically using thermal cutting or mechanical methods. The edges of both the shell opening and the patch plate are beveled to the angle specified in the welding procedure to allow full penetration welds. The patch plate, which is the same material specification and thickness as the original shell, is then fitted into the opening with proper root gap and alignment. Finally, tack welds secure the plate in position before completing the full weld. Welding over corroded material without removal does not restore structural integrity. Beveling before cutting creates an incorrect sequence. Forcing an oversized plate is impractical and damages the vessel. Question 104. When plugging a leaking tube in a heat exchanger tube bundle, what must a Boilermaker verify before driving the tapered plug into the tube end? A. That the tube is completely filled with process fluid to support the plug during installation. B. That the adjacent tubes have already been plugged to balance the pressure differential. C. That the tube end and surrounding tube sheet ligament are free from cracks and erosion. D. That the tube has been expanded with a roller expander immediately before plug insertion. The correct answer is C. Before installing a tube plug, the Boilermaker must inspect the tube end and the surrounding tube sheet ligament area to verify they are free from cracks, erosion, and corrosion damage. The plug relies on a tight mechanical seal against the tube bore and tube sheet material to prevent leakage. If the tube sheet ligament between tubes is cracked or thinned, the plug cannot form a reliable seal and the leak will continue or worsen. Process fluid should be drained, not retained, before plugging. Adjacent tubes are plugged only if they are individually defective, not for pressure balancing. Rolling and plugging the same tube is contradictory since rolling is used to tighten a tube-to-tube sheet joint, while plugging permanently removes the tube from service. Question 105. What type of refractory material is typically applied by pouring or pumping into forms and then cured in place inside a vessel or furnace lining? A. Castable refractory mixed with water and placed as a monolithic lining. B. Firebrick refractory laid in courses with refractory mortar joints. C. Ceramic fiber blanket refractory attached with stainless steel anchors. D. Plastic refractory that is hand-rammed into position using a pneumatic tool. The correct answer is A. Castable refractory is a pre-mixed material composed of refractory aggregates and hydraulic cement binder that is combined with a controlled amount of water to form a pourable or pumpable consistency. It is then placed into forms or molds that define the lining shape inside a vessel, furnace, or duct. After placement, it cures and hardens through a hydraulic setting reaction, similar to concrete, forming a monolithic, seamless lining. Firebrick is laid individually in courses with mortar, not poured. Ceramic fiber blanket is a flexible insulating material pinned to surfaces, not cast. Plastic refractory is a stiff material that is rammed or tamped into place, not poured, and does not require forms in the same manner as castable. Question 106. After installing new castable refractory in a vessel lining, what curing procedure must be followed before placing the vessel back in full service? A. Immediately bringing the vessel to full operating temperature to accelerate the curing process. B. Allowing adequate air cure time followed by a controlled heat-up at specified temperature increments. C. Applying a coat of paint over the refractory surface to seal moisture inside the lining. D. Allowing the refractory to air cure and then cooling it rapidly with water spray. The correct answer is B. Castable refractory must undergo a two-stage curing process before the vessel enters service. First, it requires an adequate air cure period, typically 24 hours or more depending on the manufacturer specifications, to allow the hydraulic cement to achieve initial set strength. Then a controlled heat-up or dry-out procedure is performed by gradually increasing the temperature at specified increments with hold times at key temperature plateaus. This controlled schedule allows moisture within the refractory to escape as steam without causing explosive spalling or cracking. Immediately raising the vessel to full operating temperature traps moisture and causes the lining to fail catastrophically. Painting over refractory serves no purpose and traps moisture. Rapid water cooling after air cure would introduce thermal shock. Question 107. During a hydrostatic test of a repaired pressure vessel, what is the standard practice for determining the test pressure to apply? A. Apply the maximum pressure the test pump can generate until a leak is observed. B. Apply half the original design pressure to avoid stressing the repaired weld joint. C. Apply the operating pressure recorded during the last production run before shutdown. D. Apply 1.5 times the maximum allowable working pressure as specified in the test procedure. The correct answer is D. The standard hydrostatic test pressure for a repaired pressure vessel is typically 1.5 times the maximum allowable working pressure, MAWP, as specified in the applicable code and test procedure. This ratio provides a safety margin to verify the structural integrity of the repair while remaining within a controlled range that will not permanently deform or damage the vessel. Testing to the maximum pump capacity is dangerous and uncontrolled, as it could exceed the vessel's design limits and cause catastrophic failure. Testing at half the design pressure does not adequately prove the repair can withstand service conditions. Using the last recorded operating pressure is unreliable since operating pressure fluctuates and may not represent the vessel's rated capacity. Question 108. Why is pneumatic testing of a pressure vessel considered higher risk than hydrostatic testing? A. Compressed air is more corrosive to vessel walls than water at the same pressure. B. Compressed gas stores significantly more energy than liquid and can cause violent failure. C. Pneumatic tests require longer hold times which increase fatigue on the vessel shell. D. Air pressure gauges are less accurate than hydraulic pressure gauges at test pressures. The correct answer is B. Pneumatic testing is inherently more hazardous than hydrostatic testing because compressed gas stores far more potential energy than an equivalent volume of pressurized liquid. Water is essentially incompressible, so if a vessel fails during a hydrostatic test, only a small volume of water escapes and the pressure drops almost instantly. In contrast, compressed air or gas is highly compressible and stores enormous energy. If a vessel fails during a pneumatic test, the rapid expansion of the compressed gas produces a violent, explosive release of energy with dangerous shrapnel and blast effects. For this reason, pneumatic tests are performed at lower test pressure ratios, require additional safety precautions such as increased exclusion zones, and are only used when hydrostatic testing is impractical. Air is not more corrosive than water. Hold times are not the differentiating factor. Gauge accuracy is comparable between the two methods. Question 109. When performing a hydrostatic test on a vessel in cold weather, what temperature requirement must be met before pressurizing the vessel? A. The water temperature must be below freezing to test the vessel under worst-case conditions. B. The metal temperature must exceed the maximum design temperature by at least 10 degrees. C. The ambient air temperature must match the vessel's normal operating temperature exactly. D. The metal temperature must be at or above the minimum specified to prevent brittle fracture. The correct answer is D. Before pressurizing a vessel for hydrostatic testing in cold weather, the metal temperature must be at or above the minimum temperature specified in the test procedure, typically related to the material's minimum design metal temperature or the brittle to ductile transition temperature. Carbon and low-alloy steels become increasingly brittle at low temperatures, and pressurizing a cold vessel risks sudden brittle fracture without warning. The test water temperature is often specified to be warm enough to maintain the vessel metal above this minimum threshold. Testing below freezing is dangerous and could cause ice formation as well as brittle failure. Exceeding the maximum design temperature is unnecessary and unrelated to cold weather concerns. Matching the exact operating temperature is impractical and not the governing criterion for safe pressurization. Question 110. A Boilermaker observes a steady pressure drop during the hold period of a hydrostatic test but cannot find any visible leaks on the vessel exterior. What is the most likely explanation for this pressure loss? A. The pressure gauge has failed and is reading progressively lower over time. B. The vessel walls are absorbing water through microscopic porosity in the base metal. C. A leak exists at an internal component such as a gasket, drain valve, or test connection. D. The ambient temperature has increased, causing the water volume to expand rapidly. The correct answer is C. When a hydrostatic test shows a steady pressure decline during the hold period but no external leaks are visible, the most probable cause is a leak at an internal or hidden connection point. Common sources include a weeping gasket on a blind flange, a partially open or leaking drain valve, a test connection fitting that is not fully sealed, or a leak on the underside of the vessel that is not readily visible. These leaks allow water to escape in small quantities that may collect in insulation, drip trays, or containment areas without being immediately obvious. A gauge failure would typically show erratic readings rather than a steady decline. Water absorption through steel is not physically possible under normal conditions. Temperature increase would cause water expansion and a slight pressure rise, not a decline. Systematic inspection of all connections, valves, and the vessel underside is required to locate the leak source. Question 111. Which non-destructive examination method uses high-frequency sound waves to measure the remaining wall thickness of a pressure vessel? A. Ultrasonic thickness testing using a calibrated straight-beam transducer. B. Liquid penetrant testing using a visible or fluorescent dye application. C. Radiographic testing using a sealed radiation source and film cassette. D. Magnetic particle testing using an electromagnetic yoke and dry powder. The correct answer is A. Ultrasonic thickness testing, UTT, uses a transducer to send high-frequency sound waves into the vessel wall. The sound pulse travels through the metal, reflects off the opposite surface, and returns to the transducer. By measuring the time interval between the transmitted and reflected pulses, and knowing the speed of sound in the material, the instrument calculates the wall thickness with high accuracy. This method is widely used to monitor corrosion and erosion in service. Liquid penetrant testing detects surface breaking cracks through capillary action but does not measure thickness. Radiographic testing produces images of internal defects but is not the standard method for routine thickness measurement. Magnetic particle testing detects surface and near-surface cracks but provides no thickness data. Question 112. What is the first step in developing a demolition plan for removing a large vertical pressure vessel from an operating facility? A. Cutting the vessel into sections starting from the top and working downward immediately. B. Ordering a crane to the site based on the estimated weight of the complete vessel. C. Conducting a hazard assessment to identify structural, chemical, and environmental risks. D. Disconnecting all piping connections and removing insulation from the entire vessel. The correct answer is C. The first step in any vessel demolition plan is conducting a thorough hazard assessment. This assessment identifies the structural risks such as vessel weight, center of gravity, and adjacent structures, chemical hazards including residual process materials, toxic substances, and flammable residues, and environmental considerations like asbestos-containing insulation, lead paint, and contaminated materials that require special handling. The hazard assessment informs every subsequent decision, including the demolition sequence, equipment selection, exclusion zones, and required permits. Cutting without assessment risks encountering unknown hazards. Ordering a crane requires knowing the load details determined during planning. Disconnecting piping is part of the execution phase that comes after planning is complete. A proper hazard assessment ensures worker safety and regulatory compliance throughout the removal project. Question 113. When dismantling a tall vertical vessel in sections using thermal cutting, what is the correct sequence for removing the shell courses? A. Cut the bottom course first to allow the vessel to settle onto temporary supports. B. Cut alternating sections starting from the middle and working outward in both directions. C. Cut all circumferential seams simultaneously and lift the entire vessel as a single assembly. D. Remove sections from the top downward while maintaining adequate support for remaining sections. The correct answer is D. When sectioning a vertical vessel for removal, the correct approach is to work from the top downward, removing one section at a time. Each section is rigged to the crane before the circumferential cut is completed, then lifted clear once the cut is finished. This top-down sequence maintains structural stability because the remaining lower sections remain fully supported by the foundation and skirt throughout the process. Cutting the bottom course first would leave the upper sections unsupported, creating an extremely dangerous collapse hazard. Cutting from the middle destabilizes both upper and lower sections. Cutting all seams simultaneously is impractical and hazardous as it would leave sections unsupported and create an uncontrolled collapse scenario. Each cut must be planned with rigging attached before separation. Question 114. What specific hazard must be identified and addressed before removing old insulation from a vessel or piping system built before the mid-1980s? A. The potential presence of asbestos-containing materials requiring specialized abatement procedures. B. The presence of fiberglass insulation that may cause temporary skin irritation during handling. C. The possibility of mineral wool insulation releasing dust particles into the work area. D. The risk of calcium silicate insulation crumbling and creating a slip hazard on the floor. The correct answer is A. Vessels and piping systems constructed before the mid-1980s frequently contain asbestos in their insulation materials. Asbestos was widely used for thermal insulation due to its excellent heat resistance and low cost. However, asbestos fibers are a known carcinogen that causes mesothelioma, asbestosis, and lung cancer when inhaled. Before removing any insulation from older equipment, samples must be taken and analyzed by a qualified laboratory to determine if asbestos is present. If confirmed, specialized abatement procedures are required, including containment, negative air pressure enclosures, wet removal methods, personal protective equipment with respiratory protection, and disposal at approved facilities by certified abatement workers. While fiberglass irritation, mineral wool dust, and calcium silicate debris are legitimate handling concerns, they do not carry the severe health risks or regulatory requirements associated with asbestos exposure. Question 115. Before using oxyfuel cutting to dismantle a decommissioned vessel, what preparation is required to prevent fire or explosion during cutting? A. Fill the vessel completely with process fluid to prevent oxygen from reaching the cutting zone. B. Coat the exterior cutting path with grease to reduce sparking during the thermal cutting process. C. Remove all fire extinguishers from the area to create space for the cutting equipment setup. D. Confirm the vessel has been purged, cleaned, and tested to verify it is free of flammable residues. The correct answer is D. Before any thermal cutting on a decommissioned vessel, the Boilermaker must confirm that the vessel has been properly purged of all flammable and combustible materials, thoroughly cleaned, and atmospherically tested to verify that flammable gas concentrations are below the lower explosive limit and oxygen levels are within the safe range. Residual hydrocarbons, chemical deposits, or absorbed substances on the vessel interior can ignite or explode when exposed to the heat of oxyfuel cutting. A gas-free certificate or hot work permit is typically required before thermal work begins. Filling with process fluid does not make cutting safe and creates additional hazards. Applying grease to a cutting path would create a fire hazard as grease is combustible. Fire extinguishers must be readily available during any hot work operation, not removed from the area. Question 116. When removing a horizontal heat exchanger from its foundation for replacement, what must be done before unbolting the exchanger from its support saddles? A. Rig the exchanger to a crane or lifting device to support its weight during disconnection. B. Drain all water from the shell side only while leaving the tube side full for ballast weight. C. Remove the channel head and tube bundle first to reduce the overall length of the exchanger. D. Weld temporary lifting lugs to the shell at random locations for crane hook attachment. The correct answer is A. Before unbolting a horizontal heat exchanger from its saddle supports, the unit must be properly rigged to a crane or other lifting device to support its full weight. If the foundation bolts are removed without rigging support in place, the exchanger could shift, roll, or fall from the saddles, causing equipment damage, structural collapse of adjacent piping, and potentially fatal injuries to workers. The rigging ensures controlled movement at all times during the removal process. Leaving one side full while draining the other creates an unbalanced load. Removing the channel head first is not necessary before disconnecting from saddles and complicates rigging. Temporary lifting lugs must be engineered, positioned at calculated locations, and welded by qualified welders following approved procedures, not placed at random locations. Question 117. What is the primary environmental concern when removing refractory lining that contains hexavalent chromium from a vessel or furnace? A. Hexavalent chromium causes rapid visible corrosion on surrounding carbon steel structures. B. Hexavalent chromium reacts with water to produce flammable hydrogen gas in the work area. C. Hexavalent chromium is a toxic carcinogen that requires controlled removal and proper disposal. D. Hexavalent chromium is an electrical conductor that can short-circuit nearby power equipment. The correct answer is C. Hexavalent chromium, Cr6, is a known human carcinogen and highly toxic substance that can be present in certain refractory materials, particularly those used in high-temperature applications. When refractory containing hexavalent chromium is disturbed during removal, airborne dust particles can be inhaled by workers, causing serious health effects including lung cancer, kidney damage, and respiratory sensitization. Controlled removal procedures are required including respiratory protection, containment of dust, wet removal methods to suppress airborne particles, and proper disposal at approved hazardous waste facilities. Hexavalent chromium does not cause visible corrosion on steel structures in the manner described. It does not react with water to produce flammable gas. While chromium is a metal, refractory containing chromium compounds is not an electrical conductor that would cause short circuits. Question 118. A boilermaker is planning the removal of a vessel that was previously in caustic soda service. The vessel has been drained but not cleaned. What specific material hazard must be addressed in the demolition plan? A. Caustic soda residue causes severe chemical burns and requires neutralization before work begins. B. Caustic soda residue will cause rapid oxidation and weakening of the cutting torch tip. C. Caustic soda residue generates static electricity when disturbed during vessel dismantling. D. Caustic soda is flammable and will ignite when exposed to oxyfuel cutting temperatures. The correct answer is A. Caustic soda, sodium hydroxide, residue remaining on vessel surfaces after draining poses a serious chemical burn hazard to workers. Concentrated caustic soda causes severe, deep chemical burns to skin, eyes, and mucous membranes on contact. Even dried caustic residue becomes active again when moistened by sweat, rain, or water use during cleaning. The demolition plan must address this hazard by requiring thorough vessel cleaning and neutralization before personnel enter or cut the vessel. Workers need appropriate chemical-resistant personal protective equipment including face shields, chemical gloves, and protective clothing. Caustic soda does not damage cutting torch tips through oxidation in a meaningful way. It does not generate static electricity when disturbed. Caustic soda is not flammable, it is a strong base that does not ignite, though thermal cutting of a vessel with concentrated residue can generate toxic fumes requiring respiratory protection. Question 119. What is the correct method for removing deteriorated ceramic fiber insulation blanket from the interior of a high-temperature vessel? A. Use compressed air to blow the fiber material out through the vessel manway opening. B. Burn the ceramic fiber in place using an oxy-fuel torch to eliminate the disposal requirement. C. Wet the material to suppress dust, remove anchors, and bag the material for proper disposal. D. Leave the deteriorated blanket in place and install new blanket material directly over it. The correct answer is C. Deteriorated ceramic fiber insulation must be removed using methods that minimize airborne fiber exposure to workers. The correct approach involves wetting the material with water or a specialized wetting agent to suppress dust generation, then carefully removing the stainless steel anchors and peeling away the saturated blanket material. The removed material is placed into disposal bags while still damp to contain fibers during transport. Workers must wear appropriate respiratory protection since ceramic fiber is classified as a possible carcinogen and the dust causes respiratory irritation. Using compressed air would create an extremely hazardous dust cloud of respirable fibers throughout the work area. Ceramic fiber has a melting point above 1260 degrees Celsius and cannot be burned away with an oxy-fuel torch. Installing new material over deteriorated blanket creates excessive thickness, poor adhesion, and trapped moisture that degrades the new insulation. Question 120. What must be done with vessel components that have been identified as containing lead paint before they are disposed of or sent for scrap recycling? A. The lead paint can be left in place because scrap metal recycling furnaces destroy all coatings. B. The lead paint should be removed by dry sanding or abrasive blasting without containment measures. C. The components must be identified and handled as hazardous material under environmental regulations. D. The components should be stored outdoors at the job site until the lead paint weathers away naturally. The correct answer is C. Components containing lead-based paint must be identified and handled as hazardous material in accordance with environmental and occupational health regulations. Lead is a toxic heavy metal that accumulates in the body and causes serious health effects including neurological damage, kidney damage, and reproductive harm. When lead paint is disturbed during demolition, cutting, grinding, or disposal, lead dust and fumes are released. Proper handling includes identification and labeling of lead-containing materials, worker training and medical surveillance, use of respiratory protection and protective clothing, containment during any paint removal activities, and disposal at facilities licensed to accept hazardous waste. Leaving lead paint for smelting furnaces releases toxic lead emissions. Dry sanding or blasting without containment creates uncontrolled lead dust exposure. Outdoor storage allows lead to leach into soil and groundwater, creating environmental contamination. Thank you for practicing with Question Bank Hub. Good luck on your Boilermaker Red Seal certification exam. Don't forget to subscribe for more exam preparation content.